How you doing, eighth grade classes? This is Mr. Kane coming to you to show you a little bit about 3-1A. The problem basically is a tile pattern which you have to extend, describe, and then figure out how many tiles are in figure 100 and kind of explain what that figure might look like. Now, prior to me starting to record this video, what I did was actually break down this tile pattern into some different parts based on their color. When I opened this tile pattern, every tile on here was red. Okay, well, for me, when everything is just all this big tile pattern, it's really difficult to see how things grow, where they grow, and then also to relate portions of the pattern to the figure number, which is really kind of key to making rules and figuring out how many are in figure 100. All right, so you'll notice that I kept this sort of like tail part in the lower left corner of the figures red. All the tiles were red when I first clicked in here. And then I broke down the rest of the pattern and I created a green portion of the pattern and a black portion of the pattern. And then I'm going to try to figure out what the rules are for each of those. The easiest one for me to see is actually the green portion, and I'm going to relate that to the figure number. So if you look at figure 2, the green portion has 2 tiles. If you look at figure 3, the green portion has 3 tiles. If you look at figure 4, the green portion has 4 tiles. Okay, so you can see that basically whatever figure number you have, the green portion is going to be that number of tiles. So I could start to build some of my other figures, and I'll just change the color here. And then also we could start with the green portion on figure 5. So we'll start there. Hopefully that's 5. 1, 2, 3, 4, 5. Okay, so remember the green portion should just be whatever the figure number is. Okay, so that's pretty easy. Let's talk about the black portion. So the black portion in figure 2 has 1, 2, 3, 4 tiles. So maybe it's just add 2. Maybe 2 plus 2 is 4. Maybe that's it. In figure 3, it has 1, 2, 3, 4, 5, 6. 3 plus 2 is not 6, so it's not add 2. Let's go back to figure 2. Figure 2 has 4. 2 times 2 is 4. Doubled. Maybe it's just doubled. Let's see if that works here. 3 times 2 is 6. Okay, it works there. Figure 4 has 1, 2, 3, 4, 5, 6, 7, 8. 8 black tiles. 4 times 2 is 8. Okay, so it appears that I found the pattern for that black portion. It seems that whatever the figure number is, you just double it. So in figure 1, 1 times 2 would be 2. Then we have 10. 5 times 2 is 10. Hopefully they'll fit. If not, we'll do our best. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, close enough. Change the color to black. Make sure they're 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. All right, so there's that portion. Now I have to figure out a rule or relate the figure number to how many tiles are in that red little tail part. All right, so in figure 2, there's 3 tiles in the red part. In figure 3, there's 4 tiles in the red part. In figure 4, there's 5 tiles in the red part. So I can see a pretty clear pattern here that basically the red tail part, it's just one more than the figure number. So, and then for figure 5, if we continue that, I would have 6. So I'm going to do 6 tiles in that little tail. 2, 3, 4, 5, and 6. Almost off the page, but we get the idea. And And then figure 1, if I go back, it's 2 tiles there because it's 1 more. I'm going to just shift this over so it'll fit. Shift things around if they need to be shifted. 1 and 2. Okay, so there is my figures completed. I would just take a screenshot of this and insert it right here. Okay, I'll do that a little later. All right, so then it asks us, what would figure 100 look like? For figure 100, I'm going to just break it down into green, black, red. Okay, because that's the parts I have. So remember, the green we talked about is always just the figure number. Okay, so in figure 1, it's 1, figure 2, it's 2, figure 3, it's 3, figure 4, it's 4, 5 is 5. Logically, then in figure 100, there's going to be 100 tiles in the green part. So I'm going to say green part's going to have 100 tiles. Black part, remember, was just double the figure number. Like figure 1 had 2, figure 2 had 4, 3 had 6, 4 had 8, 5 had 10. So you just got to double 100. 100 times 2 is 200. So we'd say the black part has 200 tiles. And then the red part, if you recall, was just 1 more than the figure number. Figure 1 had 2, figure 2 had 3, figure 3 had 4, 4 had 5, 5 had 6. Remember, it's always plus 1. So if you can add 100 plus 1, you get 101 for the red part. Okay. Well, we got a nice little breakdown there. So how many tiles would figure 100 have? We just add those together. 100 plus 200 plus 101. And we get, when I do my math correctly, I'm a math teacher, 401. 100 plus 200 plus 101. All right. So that, again, is how you would approach a problem like 3-1E. Okay. In addition to those, we have some finding rules from tables. Basically, you want to figure out what the rule is. So it works kind of like we call this a function machine. You put something into it, like the function machine, and something happens to it, and it spits out something else. So really what your job is to figure out, if I put the letter L in to the function machine, and it spits out the letter N, what is the function machine actually doing? How does it turn L into N? It does something. You have to figure out what that is. Always go in these tables where you have an input and an output. Try to figure out how W becomes Y. If you put in W, how does the function machine change it to become Y? Down here, same kind of thing. Put in hot, comes out cold. What is the function machine doing? Put in up, out comes down. What is the function machine doing? So you got to explain that in a rule. Now, these first ones got just letters and words, so like a little easier. And then as you go down here, we get numbers. So like in this function, put in the number 8, and it spits out the number 17. Okay, what happened? What did the function machine do? Look at a couple to establish that pattern. You put in the number 12, it spits out 25. What happened? And the number 10 spits out 21. What happened? Okay, and the rule has to work for every input and output value. Okay, so that is basically your assignment for today. As usual, ask your teachers if you need some assistance, and good luck with this assignment.